Hello, this is Michael Rosario from InnovativeTeams.net. Hope you're doing well, and just wanted to give you um, some insights into a fun project I'm doing with my kids. We're kind of building out like a fun snowball game, over Christmas break, and I thought you'd enjoy seeing how we're doing it. Um, so as you can see here, I have two kind of instances of the program running. This is running in client mode here, and I'm shooting snowballs out. You could see the server slash client in the Unity editor also running, receiving these snowballs. And we're going to go over the Mirror networking stack, which is the thing I'm using to make all of this happen. It's actually not that hard. Relative to some of the other options out there, and it's kind of fun. So to introduce the networking stack, check out mirrornetworking.com. You can find it here, and it can scale to a good number of clients in the hundreds for MMO style games. But we're just going to kind of focus on, a handful of users getting together in a house and seeing if we can get anything going. This style of networking is attractive insofar as if you're used to the networking stack that Unity used to promote, that they recently deprecated. This open source community has kind of taken over that technology and stack, fixed a boatload of bugs. They're really focused on trying to create improved documentation and helping the project move forward. In this framework, you're going to think in a Unity forward way, that you have one project and you're expressing both server and client concepts in that one Unity project. In their kind of architecture, commands are things that you do where the client is sending messages to the server. Client RPC is when the server is sending back messages from the server back to the client. You can go to the asset store to download Mirror Networking. That's Mirror Space Networking from the asset store. So I'm going to jump over to my Unity project and kind of delete all this, and we'll start from scratch. So you can kind of see here, I've already installed the Mirror networking stack here. I'll actually delete the scene and boot up a new one. Okay, first off, we're going to make sure that we're properly configured from the .NET runtime. So go to Build Settings, go to Player Settings. Over in the Other Settings tab, we're going to scroll down and make sure that the scripting runtime version is .NET 4. That all looks proper. We're going to add a terrain in here. We'll center this up at minus 250x minus 2 on the y minus 250z. And we'll do File and Save. At some point, we're going to create something called the Network Manager. So in the context of this project, this will be the game object responsible for instantiation of players, whether they're on the current computer or they're coming in from other clients. This is the boss of all of that. So we're not going to start with Network Manager. We're going to start with building the snowball. So to start with that, we're going to right-click in the scene, 3D object. We're going to go to create a sphere. We're going to scale this down to 0.5, 0.5, 0.5. And now we have our guy properly sized. We're going to make sure to add a sphere collider. I think that's already on there. We need a rigid body so that it participates in the physics engine. In order for mirror networking to kind of boss things around and manage things, it needs to track the identity of this object. So we're going to add something called the network identity script that allows the framework to track the life cycle of this object. I've already pre-written a snowball behavior script, but we'll talk through how that works. The snowball behavior script, the snowballs die after 2 seconds, and we're applying a force. Nothing super exciting here. It's a mono behavior. This snowball will die after 2 seconds. We're applying 1,000 units of force. So you can see we're accessing the rigid body and start. This is the pattern we're following to destroy the object after 2 seconds. And then we apply 1,000 units of force in the forward direction. So nothing super profound there. We complete our sphere by properly naming it. We'll call it Snowball. We will drag Snowball down to the assets space to create the prefab, and we'll delete it from the scene. Do File, Save, and everything is saved at this point. Next, I think we're going to actually create our player. So we'll right-click, create a 3D object cylinder. Oops, not cylinder. Let's make a capsule. So when you actually do your game, you can create your art and replace this capsule with whatever you want. We're going to rename this guy to Bot. The bot will have a network identity as well. So it can be tracked by the networking system. We also need the network transport script added. This script has a responsibility of tracking the movements of this object and its pose changes and sending all that information back to servers and clients. We're going to click the Client Authority checkbox to kind of say the source data for all this data is trusted at the clients. I think that should be all the major ideas there. We're going to add an additional script. I have another something I've already kind of written out, but we'll talk through it. It's the snowball behavior. Sorry, it's the bot behavior script. And one thing we need to connect here is this bot behavior depends upon being able to throw snowballs. So we just happen to have created that snowball prefab there. So we can go into Assets, drag our snowball into place, that'll connect the snowball to that behavior. Let's check out what bot behavior is doing. The first thing you'll notice here is bot behavior extends network behavior. That's part of the mirror networking stack. Here we keep a reference to the thing we're throwing, snowballs in this case. If you start a local player, this is a method we're overriding from network behavior. We're positioning the camera appropriately with these two lines. So if we happen to be a player who's not local to the computer, right? So keep in mind that the bot, the script is kind of controlling the behavior of our robot, whether it's being controlled by the local player or it happens to be other clients. If we're not talking about the local player, we just return. We don't care about any input behavior. If we are the local player, then we read off the fire, horizontal, vertical inputs and act appropriately. These 4 lines give you a fairly simple character controlling mechanism. The fire key calls a method called command shoot. And as we talked about in the architecture, whenever we send commands, we're sending a message from a client out to the server. So this annotation kind of facilitates that. And in turn, we're calling RPC fire weapon. So the server calls out to all the clients and says, hey, so instantiate a snowball at that point. There's a little bit of offset stuff going on there. We're raising this up in the Y direction just a little bit, but that's basically it. That when we hit fire, the client calls out, hey, shoot, and then the server does the work of instantiating that snowball appropriately. Okay, so at this point, I think we're ready to complete our bot. So let's hit save. We'll pull the bot down to assets by clicking and dragging. So now we have our prefab for that object. We go over into here and we can delete that object. At this point, we need to actually build out where will the players spawn. So we're going to add an empty game object called spawn point. We're going to add in another script called network start position. And that should take care of that. We're going to make a few copies of that. So I'm pointing at that object, doing Control-C to copy, Control-V to paste it. We'll do that 3 times. So there's 3 spawn points. We'll save. Now let's configure the Network Manager. Network Manager will have the Network Manager script. Under here, we're ignoring most everything. For this tutorial, the only thing you have to worry about is this player prefab. So we're going to link in our bot into the player prefab. We can also add in the Network Manager HUD, which will give us kind of a default interface for starting things up. And, you know, for a snowball fight with my kids, this is plenty. So I think one other detail we need to do is the player spawn method. We're going to set that to round robin. Okay, and let's see if this works at all. So let's go ahead and just run it in the editor and see if we can throw any snowballs. Okay, so here's in the upper left-hand interface, we could start the server and client together. You kind of feel this in a Minecraft client. It kind of does the same thing. So we're going to do that. I'm doing left and right. Yep, looks like I can throw snowballs. And looks like I can translate around, okay? Feeling good about that. Let's go ahead and do a build so we can see both sides of this equation of the client and the server. Okay, we're going to set this to windowed. Going to hit play. Let's go ahead in the Unity editor, start the server and client. Oh, and I'm throwing snowballs and I'm seeing them in both programs. Let's look around. Hey, look, there's the other player. Let's go in the Unity editor. Let's see if we can see it. Yep. We can see the other player. So as I'm shooting at the other player, we can see all that interactivity and we can see me moving around. So that's a quick dose of how you make a multiplayer game using the Mir networking stack. What's also cool to note, under Mir/examples, there's several other things you can kind of like learn from, which is fantastic. I found, especially in the this documentation, if you go to articles, go down to community guides, this Mir Quick Start Guide by Stephen Allen Games was very helpful to me in getting started. So I would say it's more complicated than the content I showcased in this video, but I feel like it still would be a good reference for things that maybe I didn't cover in this video. And again, if you have any other questions, reach out to me at innovativeteams.net. Always happy to help our readers and wish you the best. Take care.